which I have already uploaded into my shorts. Okay, so this is one of the question which I have uploaded the latest. Okay, so I will explain the question here. A triangle is given into a circle and AOB is the diameter, right? So AOB is the diameter, is the data which is given, and it's also given that AC equal to BC. It's also given that AC equal to BC. So if AC is equal to BC and AOB, this is the diameter, then what will happen? How to solve such questions? Okay, I'm going to explain it. Now let us see how such questions are solved. So students, it's very simple. It's very simple. You need to understand few concepts which will help you to solve such questions. Okay. The main thing is this, that any circle any circle where diameter is given, then you need to just remember that angle into the semicircle is a right angle, right? Angle into the semicircle is a right angle. So if the angle in the semicircle is a right angle, then we can say this angle is 90, isn't it? So let me solve this. Okay, I'm just coming up. That this is the circle which is given. This is the circle given, right? And this is a diameter. A, O is the center, and B. So this is the diameter which is given. So O is the center, and P is a point in this semicircle, and AP is connected like this, and PB is also connected like this, right? Now, the data given into this question is that AB equal to diameter, and another data which is given into this question is AP equal to PB. In yesterday's shorts, actually this is marked as C. Let it be C. So we need to find this angle. Angle CAB equal to what? Angle CAB equal to what? If AC is equal to BC. AC is equal to BC. So students, in such questions, just see the data given into the question. It's given that AC is equal to BC. ABC is a triangle, though this triangle is inside a circle, but this is a triangle. So if this triangle lying inside a circle and AC is equal to BC, then angles opposite to these equal sides are also equal. Since AC equal to BC, so if this is angle X, I mean to say what we have to calculate, if this is angle X, then this angle will also be equal to X, isn't it? So we can say that in triangle ABC, sum of all the angles of the triangle is 180 degree, right? Sum of all the angles of the triangle is 180 degree. So if the sum of all angles of the triangle is 180 degree, just apply the same. Just apply the same. X will be added with x. So x is one of the angle which we have to calculate, and this angle B is also equal to x. And what will be the third angle? You can see this is the diameter, and ACB is the angle into the semicircle. So this will be equal to 90 degree, right? So x plus 90 degree will be equal to 180 degree, isn't it? If this is known, this you can see this is a linear equation in one variable where x is the variable. Now x and x will add up to get 2x plus 90 is equal to 180, right? And 2x will be left into the LHS, and into the RHS 90 will go from LHS. So 180 minus 90. So here we have 90, x equal to 90, and 2 will come into the denominator of the RHS. So 90 by 2. So the value of x is 45 degree. The value of x is 45 degree here. So this is our answer. We have been asked to calculate the value of x. So the value of x is calculated as 45 degree, right? Now, this was very simple question, but few understanding you should have, that we have applied two concepts over here. Okay, one is that angle into the semicircle. So angle into the semicircle is a right angle, you always know it. Okay, so that theorem is applied over here. First point which we applied, that angle into the semicircle, which is equal to 90 degree, right? This we applied. And point number 2, angles opposite to the equal sides of a triangle are always equal. So if AC is given as equal to BC, then angles opposite to the equal sides of a triangle are always equal, right? So if AC equal to BC, then angle opposite to AC is this one, angle B, and angle opposite to BC is this one, angle A. Then angle A will be equal to angle B. So we can say if this is x, then this will also be equal to x. If angle A is equal to x, then angle B will also be equal to x, right? And we know that sum of all the angles of any triangle is 180 degree. So in triangle ABC, we applied the same, right? And just add up the values, x plus 90. These are the three angles, and when you add up, this will give you 180 degree. So this is our linear equation where we solved to get the value of x as 45 degree, right? So this question is solved. X equal to 45 degree is our answer, right? Now I'm coming to a separate question which I have put in another sorts. Okay, here two parallel lines are given. Here two parallel lines are given, and it is connected like this. I am showing you. Here it is connected like this. This triangle, these are two parallel lines. Let's say AB and C and D. These are two parallel lines, right? Now, how they are connected? This is a transversal. Okay, this transversal is let's say intersecting at some point P here on AB, and this is connected like this, right? Now we need to find the value of x and y. We need to find the value of x and y where this is x and this is y, and 50 and 127 is given as these angles. These angles are given as 50 and this angle is given as 127. Now we need to calculate the value of x as what and y is what, right? Here you can say angle x is equal to angle 50. Here you can see. Why? Because AB and CD are two parallel lines, and let's say PQ is a transversal, PR is also a transversal, right? So since AB is parallel to CD, PQ is a transversal, right? Then angle PQR, angle PQR will be equal to angle APQ. How? Angle PQR equal to angle APQ. This angle will be equal to this angle, right? So if angle PQR equal to angle APQ, why alternate angles? These are alternate angles. Then angle X is equal to 50 degree, isn't it? Then X is calculated as equal to 50 degree. It's very simple. Now if you want to calculate the, if this is 50 which is known to us now, what is the value of y? Y is calculated, you can see, if PR is also a transversal, since PQ is a transversal, PR is also a transversal, you can see. Then by applying the same alternate angle concept, we can say angle APR equal to angle PRD. Angle APR equal to angle PRD, right? PRD is, why these angles are equal? Alternate. These are alternate angles. So if angle APR is equal to angle PRD, what is the value of angle PRD? It's 127 degree, right? And what is the value of angle APR? Angle APR. This is this angle. I mean to say 50 plus y. So 50 will be added with y, right? So 50 plus y is the value of, is will be equal to angle PRD, and angle y is calculated as 127 minus 50, that will be equal to 77 degree. So y is equal to 77 degree. 7, yeah, y equal to 77 degree is our answer. So this is y, this is y, and y is equal to 77, and x equal to 50. So x equal to 50 we have already calculated, right? And y equal to 77, this we have shown to you, right? Now students, I think in this question you are you understood the basic concepts how to solve such questions. Also, I will just put the sorts of these questions. I am just coming in the live session to explain those sorts, so that if there is any queries, I can handle those into the live sessions, right? So I have explained this question, okay, and I have explained the question, this one, the triangle inside the circle, and if AB is the diameter given and AC equal to BC, this is also the data given. We need to calculate the angle CAB. That means this one. So we applied the same concept, that angle into the semicircle is 90 degree, right? And second concept we applied, that angles opposite to the angles opposite to equal sides of a triangle are always equal. So the angles opposite to the equal sides of a triangle are equal. So that's why, and the sum of all the angles of a triangle is 180 degree. So that's why angles opposite to the equal sides are x and x. We have put this value over here plus the third angle, and all this sum will be equal to 180 degree. So this I have just explained it, right? Now I want to take some more questions. So let me come up with those questions now. Okay. I want to take some more questions based upon this. So I'm just finding some more questions. Let me find out with some more queries. If you can, if you are having any doubt, you can put up into the. So here we have explained the things. So let me come up with some more questions of circles. Okay, and I want to bring some more questions. So I'm taking another question, that this is a, I'm just taking another question, that if a triangle is given like this, if a triangle is given like this, a circle is given like this, and AB and AC are two equal chords. This is A, B, and this is AC. These are two equal chords. If AB and AC are two equal chords whose center is O, so if these are the chords of this circle, let's say this is the center O, right? And OD is perpendicular to AB. This is the data given into the question. If OD is perpendicular to AB, right? And OE is perpendicular to AC. OE is perpendicular to AC. So these angles are 90 degree, mind it. These angles are 90 degree, right? So the data given into the question, AB equal to AC equal to, these are the chords. These are the chords, equal chords. These are equal chords. And it's also given that OD and OE are OD is perpendicular to AB, and similarly OE is perpendicular to AC. This data is given into the question. Now we need to prove that ADE is an isosceles triangle. So where is triangle ADE? Just see it. ADE. So if this is connect D and E is connected like this, then we need to prove that angle ADE, this triangle ADE equal to isosceles triangle. This you need to prove it. This is the question. Now what we will do? How we will prove that triangle ADE is isosceles? Let us see it. Here it's given AB equal to AE. Since AB equal to AE, can't we say that the equal chords are equidistant from the center of the circle? So if AB equal to AE, this is the data which is given. If AB equal to AE, OD will be equal to OE. So since equal chords are equidistant, from the center. So if AB equal to AE, AB equal to AC, since AB is equal to AC, we can say that OD is equal to OE. OD equal to OE. This one. This OD is equal to OE. Right? So this we have identified by application of the theorem that equal chords are equidistant from the center for the same circle, right? And it's given that AB equal to AC. These are the equal chords. Now, in the triangle ODE, you can see this. This is a smaller triangle which is just hanging towards the center. ODE. ODE. In triangle ODE, so I'm writing in triangle ODE. In triangle ODE, since this is equal to this, OD equal to OE, so we can say that this angle ODE, let's say this one, will be equal to this one. I mean to say that angle ODE equal to angle OED, since OD is equal to OE, right? So these chords are equidistant from the circle. These chords are equidistant from the circle. So that's why OD equal to OE. This is OD and this is OE. And these are equal, then we can say that angle ODE equal to angle OED. What is that angle? This is angle 1 and this is angle 2. So we can say that angle 1 equal to angle 2. I'm just writing ODE as angle 1 and OED as angle 2. This one. These are smaller angles, right? I hope you are able to see it. So this will be equal. Now, if these are equals, then can we say that if angle ADO is 90 degree, 90 minus this equal angle 1, and here also in triangle AEO, or here angle AEO, 90 minus angle 2, these both are equals. So subtract equal angles from 90, so you get this angle, this one, and this one as equal, right? Because angle 1 is equal to angle 2, so subtracting these equal angles 1 and 2 from 90 degree, from the both the sides of these 90 degree angles, you get these angles are equal, here marked in two lines. These angles are equal, isn't it? If these two angles are equal, if these two angles are equal, these are the angles opposite to the sides AD and AE. Are you able to understand? I want to explain it again. Okay. AB and AC are two equal chords. OD is equal to OE, chords equidistant from the circle. Now, what is the next? The next thing is that angle 1 will be equal to angle 2. Why angle 1 will be equal to angle 2? That means angle ODE is equal to angle OED. Why this will be equal? These will be equal because equal chords are equidistant. So, we can say that OD equal to OE. So, in the smaller triangle DOE, in the smaller triangle, if this is D, this is O, this is E and this is O, then here this angle is equal to this angle because OD and OE are equal. Here OD and OE. I am just explaining this same figure over here. Okay, if these two angles are equal, then let's say this is angle 1 and this is angle 2. So if you are subtracting from 90 degree, you are subtracting angle 1, and similarly from 90 degree you are subtracting angle 2, and 1 or 2 are equal. Isn't 90 minus 1 is equal to 90 minus angle 2? So 90 minus angle 1 is what? Angle D. This one, angle ADE. Similarly, this is equal to angle AED. That means 90 minus 2. And these are the angles opposite to the equal sides. Because these angles are equal, we can say AD equal to AE. So we have proved that ADE is an isosceles triangle. Isn't it? I'm saying that if angle 1 equal to angle 2, because these chords are equidistant, so OD equal to OE. So if OD equal to OE, if these lines are equal, right, these perpendiculars are equal, then angles opposite to these equal perpendiculars are also equal. So angle 1 equal to angle 2. Sorry. So if angle 1 equal to angle 2, we can say that 90 minus angle 1 equal to 90 minus angle 2, right? Sorry. So 90 minus angle 1 will be equal to 90 minus angle 2. So we can say that these angles, angle ADE, so we can say that angle ADE equal to angle AED. And these are the angles opposite to the sides AE and AD respectively. So opposite to ADE, this is AE. So we can write AE is equal to opposite to angle AED. That is side AD. So we can say that AE equal to AD. So if AE is equal to AD, here, if this side AE is equal to AD, this one, if these two sides are equal, we have proved it. Then ADE is an isosceles triangle, isn't it? Then triangle ADE is an isosceles triangle, right? So we can say that triangle ADE is isosceles triangle. So we have proved it, right? Now, I think you are able to understand this question. I want to see any doubts you are putting. You can put into the chat. Okay. Let me see. 1 minute. Yes. So I will take up some more questions today. Let me see if any queries coming into the chat. I want to solve that. Okay. So we have explained the question, this question, where a circle is given, AB, AC are equal chords, OD perpendicular to AB, OE perpendicular to AC. Since equal chords are equidistant from the center, so that's why we have we have considered OD equal to OE, because the distance of any chord from any point is the perpendicular distance. Okay, so OD is perpendicular to OE, that is the shortest distance. So we can say OD is equal to OE. Similarly, if OD equal to OE, we can say in triangle ODE, angle 1 equal to angle 2. What is angle 1? What is angle 2? I have shown you. Okay, what is 1 and what is angle 2? I have shown you. Now we have proved it. Since angle 1 equal to angle 2, 90 minus angle 1 is equal to 90 minus angle 2. 90 minus angle 1 will be this angle, line with double lines, angle with double lines, and this angle with double lines. This is 90 minus angle 2, right? So 90 minus angle 1 is equal to 90 minus angle 2. So we can say that angle ADE is equal to angle AED, which are the sides opposite to the equal. If these angles are equal, then the opposite sides corresponding to these angles are also equal, isn't it? If this is the case, then triangle ADE, this triangle ADE, which we have just started to going it, which we have started to prove it that this is isosceles, we have proved it, because angle D equal, this angle ADE is equal to angle AED. These are the angles opposite to the equal sides. So AD equal to AE. So we can say that triangle ADE is isosceles, right? I'm taking some more questions, students, so that, so I have already put the sorts of these questions earlier. So I am just explaining those questions over here, so that any queries coming which you are having in your mind, you can put up over here, and I will be explaining those questions, right? So I want to take some more question. Let me see what I will be. Now in this question, we have proved that triangle ADE is isosceles, right? I want to take more questions. Let us see what are the questions which I want to take. Let me derive some questions from the book. Or even I can do one thing. We can use the test, you can use the questions paper to solve. Okay. So I'm thinking that if the questions paper will be coming to you, it will be beneficial. However, that will be more advantageous to you, right? So students, I think you have understood these questions which I have explained today. Now, I have explained the earlier sorts, this question and the question which I have explained earlier, that is, 1 minute. This question I have explained, okay, and I will just say that keep on learning, and I am taking some more questions with you. So I am looking for my previous sorts so that I can explain it. Okay, just be here and let me see the chat if any queries coming from your side. Yes, yes. So in the previous sorts I've explained that AOB, the diameter is equal to BC. That question is explained, and X and Y value, this question I mean to say, this is also explained, and boat Ritu going downstream and upstream, that is also explained. Air volume inside the tire is also explained. Charges Q1, Q2 are placed just to neutralize those charges, that is also explained. AP is explained. So students, I think we have explained almost questions which we have. Yeah, even the month for the mensuration we have explained. So medians we have explained, cloud. So I think we are okay to go ahead. So I will come up with the next live session to explain more concepts and queries. Okay. Thank you so much for watching. Take care and happy learning. Bye bye.